Hello guys, welcome back to Maison African Motives, still on mathematics N4, that is working on derivatives, that is differential calculus. In this case, we shall be focusing on the product and the quotient rule. We want to see how actually are we given the questions and how we're supposed to attempt those typical questions, whether it's on quotient rule or it's an product rule. Okay, so without wasting much of our time, what I'm just going to do is to introduce you to what exactly we are referring to between these two, the product and the quotient. When you are referring to a product from our understanding, this is a multiplication that is happening. So we are saying there are two functions that you're working with of x or f of x, or it can be f of y, whatever function that you're given, but there are two functions that are being multiplied together from the word product. They are being multiplied together. So let us take for an example that y is given as ux, which is a function of x times vx, like this, where u, it's a function of x, and also v, it's a function that also consists of x. So this is a product. These two, they are being multiplied together. Just for an example, we've got two functions. Y is equal to e to the exponent of 5x times the cosine of 3x. That's a product. These two are functions of x being multiplied together. So that is how we can see a product. It must be from a multiplication. So once you see that this is a product, therefore, it follows that the derivative of y with respect to x, which you are also given on your formula sheet. All right, so let me just have it here. That is the derivative of y with respect to x will be equal to, from this ux, vx that we are going to have our formula as ux times the derivative of vx in this case. All right, then we add in this case, the derivative of u, this time u, we are going to have the derivative of ux times vx. So like I said, you are also given this on your formula sheet. So what you simply need is to locate or to tell what is the function that is going to represent the u part of your function and what is going to represent the u part of your function. Then once you can tell this, you can find the derivatives, substitute into the formula of which you're given the formula from your formula sheet. So that is your product rule. Shall see examples as we move on. Then we move on to the quotient rule in this case. So quotient rule is on a condition whereby we are dealing with division. So quotient rule is on a condition whereby we are dealing with division in this case. So this is on division. So product, that's multiplication. All right. So once you're given two terms or expressions of x dividing to each other, for example, y is equal to ux over vx, like this, that's a division. This is a function of x. This is a function of x divided to each other. Therefore, the derivative of y with respect to x on this manner is going to be given by this formula, which is also on your formula sheet. That's vx times the first derivative of u minus ux in this case times the first derivative of v, everything over vx squared. So we are going to take the function of v in the denominator, this one in the denominator, you're going to square that function. So this is going to be vx squared. So you're also given this part, like I said, in your formula sheet. So all you need is to understand what exactly the formula represents and how are you supposed to apply your formula. So as you can see, it's on a division. This is the u part of your function and the v part of our function is in the denominator. So always it's taken like that. All right, so let us check the first part of our question here. Differentiate the following by using the quotient rule. Always you're told the method to apply. So in this case, you're told to apply the quotient rule to differentiate y is equal to tan x. We know this from our formula sheet. Actually, we know the answer because we are given that the derivative of tan in this case gives us sec squared x. We know the answer already. It's there on our formula sheet. But they are saying we are supposed to work with the quotient rule to find the answer that we already know, that the derivative of tan x gives us sec squared x. So what we need is to have this, but using the quotient rule. And if we can check on quotient rule, it's on a condition where we are dealing with a fraction, ux over vx. So how can we make the tan to be a fraction? How can we write this tan here to as a fraction? So remember from our trigonometry that it's the tan of x can be written as the sine of x, everything over the cosine of x. So that's sine over cos. So as you can see, we've got a fraction in this case, which can be taken as u and what? And vx in this case. So meaning to say, in this case, we are having this part on top as our ux, this part here as our vx. So meaning we are going to take these ones aside. So let us just take these ones aside so that we can be able to differentiate each. As we can see, we need the derivatives from our formula. So we are going to have our ux. In this case, we said this is sine of x. So we are going to have this as the sine of x. And from the ux that we said is sine of x, we need its derivative. Its derivative from our formula. Here we are saying we need the derivative of u. We also need the derivative of v. So we are going to find the derivative. That is now we are using our standard form. Remember from our standard form, we talked about this, that sine changes to cos. So the derivative of sine, we said this one gives us a cos. All right, we move on to cos, which is our vx in this case. So our vx is a function of cos, which is the cosine of x. Also, we saw that from our formula, we need the derivative of v also is needed. And we say the derivative, of course, it's a negative sign, which is also, you are given this in your formula sheet. So this is negative sine x. Once you have these, all you need now is to substitute back into the formula. That is our quotient rule, because this is under quotient rule. So whatever that we have here, we need it back into the formula now. Remember our formula. Okay, let us just have our formula aside. Remember our formula, I say that the derivative of y with respect to x is given for quotient rule. That's vx times the derivative of u minus, in this case, we are going to have ux times the first derivative of vx, in this case, everything over vx squared, like this. All right, so this is what you're going to have at the end. So meaning to say, all we need is to substitute into the formula, guys. You are given the formula, you have your derivatives, and everything that you have listed here. So all you need is to substitute back into the formula now that we have here. So therefore, we can say that our derivative of y with respect to x is equal to vx. Our vx, in this case, this is our vx, which is cos. From this part, we said vx is cos. So we are going to have the cosine of x being multiplied to the first derivative of u, the first derivative of u, which is also cos x. So we are going to have cos x multiplied to cos x, like this, minus ux. This one is ux, the function of u with respect to x, which is sine x. So we are going to take this as sine x multiplied to the first derivative of v, the first derivative of v in this case, which is negative sine x. So this is going to give us negative sine x, like this. All right, so that is what we have, everything over vx squared, which is, we are going to have everything here over vx. Our vx, remember here, it's cos x. So this is going to be cos x, everything being squared in the denominator. That's vx squared. So you have the formula, guys. You are given the formula. By the way, that maybe you may have forgotten the formula. You are given the formula. All you need now is to work on your formula to understand, what does this part mean? Vx is the original function of v. The first derivative, remember we talked about the formats of a derivative. This means the first derivative, but of u, which is u, is this function on top. So to list them down like this is the best. All you need now is to substitute into the formula. From there, you can simplify further. All right, so let us simply, remember we said our answer here is supposed to be sec squared, because we know this derivative for tan. So we need to simplify until we obtain sec squared x. All right, so what's going to happen here? let us see, let us simplify. We can multiply the cos and the cos here. So we're going to have the derivative of y with respect to x. Cos times cos, that's cos squared x. Here we've got negative times negative, which is a positive, sine and sine, which gives us sine squared x. All right, everything over the cos squared, cos x squared like this is the same as, remember, I said cos x to the exponent of n can be written as cos to the exponent of nx like this. So the exponent here affects the cos direct on cos. So meaning to say this is the same as cos squared x. All right. Back to our trigonometry, we understand that cos squared plus sine squared is equal to 1. This is our Pythagorean identity. We are also given this Pythagorean identity, which gives us a 1. So meaning to say this whole part is going to give us 1 over cos squared x. And also in our trigonometry, understand that 1 over cos of x gives us sec x. So if it is giving us sec x, then it means if this is cos squared, this is going to be sec squared. The exponent that is here is the same exponent that affects also on your sec. So it means here 1 over cos squared x is going to give us sec squared x in this case. So therefore, that is what you're going to have at the end, which is the answer exactly that we were expecting to have from our simplification. Like I said, you know the answer for tan, that once you differentiate tan, you are supposed to get sec squared, but you are supposed to apply the quotient rule, which means you need the formula. With your formula, substitute your values. And I said, whenever you're dealing with derivatives, think again on your trigonometry. It goes hand in hand. Like whenever you've got a trig like this, you saw that this application, we are back to our trigonometry on this part. So that is how we can actually apply or use our quotient rule in this case to have derivatives of fractions whenever you've got a fraction. All right, so there are so many questions that you can actually have which needs us to apply or to use the quotient rule, like this other part. Question number 4.4, use the quotient rule to differentiate the following. Given y is equal to the square root of x over x plus 4. So we saw from our formula, what we need is to have ux and vx. This is a fraction, so we are going to have this as our ux and this as our vx. So we can just write aside these terms. So we are saying our ux in this case is equal to the square root of x. The square root of x, we understand this is same as x to the exponent of a half. So this is what we know from our laws of exponents. And we saw that from our formula, we are going to need the derivative of this. So let us find the derivative with respect to x for this u. So remember, this is from our general rule where we multiply here by the exponent, which is half x. Then we subtract a 1 on the exponent. Don't forget this part, the first law of your derivative. So this is going to give us a negative half if we subtract 1. All right, so that is from ux in this case. We do the same thing on our vx, which is x plus 4. So we are going to have our vx in this case, which is our denominator. In this case, that's x plus 4. So that's x plus 4. Then we need its derivative, the derivative of v with respect to x. So with respect to x, here, if we differentiate this x, this is same as 1x. So we are going to obtain 1 in this case. So this is going to be 1. 4, it's a constant. So the derivative of a constant, remember, that's a 0. So there's nothing that you're going to have here. So this is what you are going to obtain, or the information that you are obtaining from your from this fraction that we have. Now we can bring back our formula, substitute everything that you are given. Remember our formula always, I'm just going to rewrite this so that we properly understand what you are referring to. So this is Vx times the first derivative of u minus ux times the first derivative of v, everything over Vx squared. So that is what you're going to have. The denominator is the one that you raise to the power of 2. So from this information that we have listed here, all we need is to just substitute our values. So we are going to have our derivative of y with respect to x. All right, so let me just have it this way. The derivative of y with respect to x is equal to the vx. Our vx here, that's x plus 4. So you can just even write it in bracket or just write x plus 4 like this. Or the best way, let us just open a bracket for this, times the first derivative of u, and we have the first derivative of u in this case here, which is half x to the exponent of negative half. We can even simplify this so that we can properly substitute this one. Remember, to the exponent of negative half is going to give us 1 over. So it will be 1 over 2 x to the exponent of half, which is same as 1 over 2 square root of x. So this can be written as 1 over 2 square root of x in this case in simplest form. All right, so you can just have this in simplest form. So we are going to substitute as 1 over 2 square root of x. So multiplied to 1 over 2 square root of x like this. All right, minus ux. Our u in this case is this part, which is square root of x, which this one was just rewriting so that we can simplify the derivative, but our ux is the square root of x. So this is going to be the square root of x times the first derivative of v. The first derivative of v, in this case, it's a 1. So we're going to multiply this by a 1. All right, so that's it. Everything over vx squared, our vx, which is x plus 4. So that will be x plus 4, everything to the exponent of a 2. That's vx squared. All right, so that's it. You can simplify just to rearrange your answer in a proper manner, or here we can just multiply, because this is same as over 1. Remember, every whole number as a fraction is over 1. So we can multiply the numerator to the numerator, the denominator to the denominator, that is x plus 4 times 1, which is going to be x plus 4 over 1 times 2 square root of x. This will be 2 square root of x like this. Then here we can multiply the square root of x and a 1. So this will be negative square root of x. All right, so that's it. Everything over our denominator here, which is x plus 4 squared. So everything is over x plus 4 squared like this. All right, so the simplification later on is actually unnecessary, because here we do not have any other mark that we are going to have. Yes, you can try to factor out what is common, this and that. Yes, there's so many things that you can actually apply, which is fine, but this is what you can just leave your answer as. You can actually obtain your full marks in this case. All right, so this is how we are supposed to have the application of the quotient rule. All right, so let's check other questions that you're given so that we can see also other rules that we are having, which is the product rule. So in this case, differentiate the following by the use of the product rule. So normally this will be actually 4 marks for that product rule, quotient rule. Normally it's just 4 marks, 4 marks. All right, so we are asked here to apply or to use the product rule. As you can see also here, it's a product that we are seeing here. These two terms, e to the exponent of 5x sec 5x, it's a product of 2 in this case. So meaning to say, we are supposed to apply the product rule, where we said this will be our ux and this will be our vx. And our formula, we are given this in our formula sheet. So depending with the arrangement that you're given, when I'm saying the arrangement, okay, let me write the formula. We are given as ux times the first derivative of b plus, in this case, we are going to have the first derivative of u times vx in this case. So like I said, it depends. You can even start with this side here. On this, we can start with this side. This side, you add, it's one and the same thing, because you are adding in this case. So there's no need for you to say, this is always the side that you can start with. No, you can even start your formula by this side. Also here, you can interchange this. You can start with the first derivative of v times ux like this. It's the same thing. So it does not matter how you're going to present your formula, as long you understand that formula that you're presenting. All right, so as you can see, there is a need for us knowing our u and its derivative. v and its derivative. So this is what you're going to do, just like the previous part. All right, so let us locate here. We said our ux is the first term, so ux is going to be e to the exponent of negative 5x, and our vx in this case taken from sec. So this is from sec 5x. From our derivatives, the standard form that we had, we talked about how to differentiate e in this case. All right, so we are given e to the exponent of negative 5x. Whenever you're given e, as long this is e, just know that you're going to find the derivative of this part. All right, so it's the derivative of negative 5x, which is negative 5 in this case. All right, so let me present it this way. So we need the derivative here. So I'm saying you are going to find the derivative of this part, which is negative 5x, which is going to be negative 5. Then you multiply to that e, which is e to the exponent of negative 5x. So in short, let me present it this way. Whenever you are given e, let us put it this way. The derivative with respect to x of e to the exponent of ax, if it is a linear part ax, that's a linear, this one. So our answer is going to be a times e to the exponent of ax. We are done. So that is what you need if you're dealing with e, as long as you're dealing with e. But if it is e to the exponent of x, the answer is just going to remain as e to the exponent of x. So that is it. So here, if you work out this one, our a in this case is negative 5. So that's why we are having negative 5 here. Then e to the exponent of ax, it remains e to the exponent of negative 5x. All right, so that is how we can attempt this question for e whenever you're given e. All right, then sec from our derivative, sec is going to give us sec x tan x. But take note of what we are given here. There is a 5. I talked about this on the introduction, that the 5 will multiply your answer. So meaning to say, we are going to have our answer as 5 sec 5x tan 5x. So on your formula sheet, you are just given that sec x is sec x tan x. But if there is a number now that is affecting, that number multiplies your answer. All right, so that is this part. I'm just talking about this, but I referred to this previously on the standard form video. So make sure that you watch that video so that you understand some of these derivatives, so that you can quickly understand the rules now, not this part, because this one is another part on its own. All right, so anyways, guys, we have our derivatives. All we need now is to substitute into the formula. So dy dx is equal to our ux, where we said our ux is this part of e. So that's e to the exponent of 5x times the first derivative of v. The first derivative of v is this part, which is 5 sec. So this is 5 sec 5x times tan 5x, tan 5x, like this. All right. Then we are going to add the first derivative of u, the first derivative of u in this case, which is this part, which is the negative 5 e to the exponent of negative 5x times vx. Our vx, the function of v, it's sec 5x. So this is sec 5x, like this. So this is multiplied together, or this is a single term. Now it's represented like as a single term. So at the end, we can just leave our answer like this. Guys, when you are dealing with the product rule, the quotient rule, the simplification in our syllabus is not necessary. The substitution into the formula like this, we are done. Yes, you can go on to factor out e to the exponent of 5x, 5 here, and sec 5x, which is fine. But in our syllabus for mathematics and for just to substitute into the formula in the simplest way as it is like this, you are done. So that is how we can have our product rule and our quotient rule. We do not have much simplification that is needed. So like I said, if you can write your answer like this, they will actually mark everything fine in this manner. Right, there's another question that I need to check up. This one, it's not as much clear. I'm just gonna check out what's happening there. All right, so let's see. Here we've got another question again on the product. So just like the previous case, you can see here, we are asked to apply or to differentiate with respect to x using the product rule in this case. And this is sec x times tan x. These are two functions being multiplied together. So this is simply our multiplication that we are having. So meaning to say we have got our u and we've got our v, just like the previous part. All right. So this is how you can play around with your product rule in this case. All right. So let us have this as our ux, this one as our vx. So just like the previous part, if our ux is sec x, we are going to need its derivative. The derivative of sec x we are given from our formula sheet. This is sec x tan x. So we are going to have sec x tan x. So here we do not have a number like 5, like 7, like the previous part. This one is just direct. All right. Then we move on to ux to vx. So the v is the last part here, which is tan x. So we are going to have this as tan x. Also, the derivative of tan x we are given in our formula sheet. Remember, tan, it's sec squared x. So these are the derivatives and the original functions that we have. So all we need now is to substitute back into our formula, remembering that we say the derivative of y with respect to x is going to give us ux, the first derivative of v, plus, in this case, the first derivative of u times vx. All right, so let us substitute into our formula and see what we are going to have. Our ux in this case, that is being sec x. So we are going to obtain sec x in this case. All right, times the v, the first derivative of v, the first derivative of v in this case, that's sec x squared. So this is sec x squared like this. All right, plus the first derivative of u, the first derivative of u in this case, which is going to give us sec x tan x like this, being multiplied to vx, the original function of v, which is tan. So this is going to be tan x like this. Yes, I said the simplification part is not necessary, but here you can see that some of these terms, they can even be multiplied together. The factorization part is the one that is not necessary, but here we can just multiply sec x times sec squared x. So it's a product there where this is same as to the exponent of 1. So you add exponents. So it is going to be sec to the exponent of 3 x. Remember, from exponents, the exponents are the same. You can simply add, if the base are the same, you can simply add the exponents. So sec and sec are the same. So you're going to add 1 plus 2, which is 3. All right, the same, you've got tan and tan, which is going to give us tan squared. But we've got sec x, so it's going to be sec x tan squared x. So like I said, once you are at this stage, you can leave your answer like this. Yes, you can factor out sec x, which is common, or you can just leave your answer like this: sec cubed x plus sec x tan squared x. All right, so this is how you can have or present your final answer as. So all you need, guys, when working with the quotient rule, understand your formulas. Product rule, understand your formulas. Each and every part that you're given, know how to substitute and how to simplify further. Just like this question that you're given, again, to differentiate the following by using the quotient rule. So this is y is equal to, okay, let me just try to rewrite it again. Y is equal to ln x to the exponent of 3, everything over ln x. So everything is over ln of x. And we are asked to apply or to use the quotient rule in this case. All right. So just like the previous cases that we had, in order for us to have the quotient rule, we know that from our formula, the derivative of y with respect to x is going to give us a vx. So that's vx times the first derivative of u minus ux times the first derivative of vx, everything over vx squared. So this is what you're going to have. But in this case, where do we have our v, our u? From the numerator denominator. So this is going to be your ux vx. All right, so let us take this aside. Since we said our ux is equivalent to ln x to the exponent of 3. And we know that we are going to need or to find its derivative later on. And I talked about this from the introduction that whenever there's a lien, it's a log. So drop the exponent that you're given, which is the 3, so that you can be able to differentiate this properly. So if we drop the exponent, it simply means this is same as 3 ln x. From our laws of logarithms, this can be multiplied to a log. So that means this is the same format. All we just need here is a format that you'll be able to differentiate it later on. So as we can see, now we can be able to differentiate the ln. Remember, the derivative of ln is given as 1 over x. So if there is a k like this, it's k over x. So our k in this case is 3. So the derivative here is going to be 3 over x. The derivative of k ln x is k over x. Our k is 3. So it's going to be 3 over x, all right? So that is what you're going to have. Then we move on to our vx. Our v, it's ln x again. So our vx, it's ln x. This one is in simplest form. So the derivative here, we are going to find the derivative of v, which is the derivative of ln x. So this one is simply 1 over x. So remember, the constant here is 1. So if it is k over x, it is going to be 1 over x. That is our constant in this case. All right. So with this information, this is enough, guys, to determine the derivative of y with respect to x. All we need is to substitute into the formula the vx that we have here, which is ln x. 1 ln x is just ln x here. So we are going to have ln x multiplied to the derivative, all right? So this is going to be ln x multiplied to the derivative of u with respect to x here, which is 3 over x. So we are going to multiply to 3 over x minus ux, our u in this case, which is ln x to the exponent of 3. Remember, the 3 ln x was just rewriting so that we can be able to differentiate, but the original ux is ln x to the exponent of 3. All right, times our first derivative in this case for v is going to be 1 over x. So we're going to multiply this to 1 over x. All right, everything over vx squared. So our vx is ln, this ln here. So it is going to give us ln x squared. Take note, we are also squaring this ln. So the ln squared is there. All right, so you can actually leave your answer like this. The same, because we do not have any multiplication or that we need. So you can leave your answer like this, or you can multiply this part here. Ln x times 3 over x is going to give us 3 ln x everything over x in this case. Then minus ln x cubed times 1 over x, it is going to be ln x cubed everything over this x here. But don't forget that there is a ln x squared in the denominator. So you've got ln x squared in the denominator. So you can write your answer like this, or you can leave your answer like this. So this one, be careful. If you're working with some of these question papers, you see that this was actually an error not to write the ln x squared. Is supposed to be there, because remember, on our derivative, we've got vx squared. So be careful on your simplification that you do not leave out any term or any part that you're given there. Do not leave any part. All right, so that is how you can have these. Also another product. So we have got a product in this case, given y is equal to the square root of x into x squared plus x plus 1. So it's very rare to have an algebraic versus an algebraic, but like this, we've got algebraic versus algebraic. So we are going to work with it. So this will be our u, and this will be our v in this case. So let me just write, maybe it's not that clear. So it's y is equal to the square root of x into x squared plus x plus 1, like this. All right, so we are asked to apply differentiate by use of the product rule, which means we need to apply or to use the product rule. So as we saw that from our product rule, we are going to need ux and vx. So this is the first function, the second function. So if we are saying in this case, all right, we can just even write this aside, we can properly see. If we are saying our ux in this case is the square root of x, so it simply means we are having this as x to the exponent of a half. And from our formula, we are going to need its derivative, the derivative in this case of x to the exponent of a half. We drop the exponent, which is a half x. We subtract 1 on our exponent. So this will be a negative half. So you can even simplify further. This one, we talked about it before. We ended up with something like 1 over 2 square root of x. I think this one, guys, we are now used to this. We talked about this type. All right, then we move on to our v, which is this whole expression that you're given in this case. So we are saying our vx is this whole part of x squared plus x plus 1. So we are going to need its derivative, and we know that the derivative, we are going to find each term, x squared is 2x, x is going to give us a 1. So this is what you're going to have in this case. All right. So with this information, let us put in our formula. Remember, we are dealing with the product rule. We are dealing with the product rule where we are saying the derivative of y with respect to x is going to give us ux. So rewriting the formula is just for you to understand what we are actually referring to. That is what we can actually have